Okay, so if we remember from day 1, are you allowed to have a first term being negative? No, never. Okay, so I am going to factor out a negative 1. You never can have your first term, which we call our leading coefficient, that can never be negative. So I'm going to factor out a negative. When you factor out a negative 1, what does that just do to all of your terms? What does negative mean? It means the opposite, so you're just changing all the signs to the opposite. So this is a positive x squared, a positive 12x, and a positive 36. Are there any more like terms? Or not like terms, sorry. Are there any more common factors? Is there any factor that all 3 of those terms are divisible by? Nope. Okay, so we're going to list out our A. What's your A? 1. Remember, it's your x squared coefficient. Don't include x squared when you write your 1. What's your B? 12. Very good. And what is your C? 36. Very good. So A times C is, and then B goes on bottom, which is 12. A times C on top, B on bottom. Go to your calculator, and we are going to do 36, the top number, divided by x. Always the top number divided by x. Again, should we all be doing this with me on our calculator right now? Yes. So go to your table. 1 plus 36, 37. 2 plus 18 is 20. 3 plus 12 is 15. 4 plus 9 is 13. Skip 5 because you get a decimal. 6 plus 6 is 12. So what's my factor pair? 6 and 6. 6 times 6 gives you 36. 6 plus 6 gives you 12. So I'm going to rewrite my expression. X squared. I'm going to replace my 12x with plus 6x plus 6x, and then plus 36. First term, first box. Last term, last box. Middle terms go in the middle boxes in your diagonal. What are x squared and 6x both divisible by? X. What are 6x and 36 both divisible by? 6. What are x squared and 6x both divisible by? And what are 6x and 36 both divisible by? Check yourself. X gives you x squared. X times 6 is 6x. X times 6 is 6x. 6 times 6 is 36. So we factored it correctly. So I'm going to rewrite my simplified expression. Do not forget, we took out that GCF of negative 1 at the beginning. So when I write my factored form, it's going to be negative 1, then parentheses. Before I write it, bless you, what do I notice about these two binomials? They're the same. If they're the same, do you have to write it twice? You can write it once, then do what? Square it. Add the squared. This is how you will see it as a multiple choice, and you probably won't see the negative 1. You'll just see a negative. But this is how you would see it as an answer choice on your test. If you wrote this as negative 1 parentheses x plus 6 times x plus 6 on a free response question, would I count that correct? Yeah, that is correct. But this is how you'll see it on a multiple choice question. Okay? What should I do next? Check it. Go to your calculator. Go to y equals. Type in your original. Then arrow down and type in your answer. Graph it. And they outline each other or overline each other. Go to the table and do the values match on the y1 and y2. Yeah, because we did it correctly. Good? How are we feeling after doing so many of these same problems, guys? How are we feeling with factoring? Are we liking that we did this unit kind of slow? Did factoring like every single day? Same thing every day? Okay, next one. Is there a number that 428 and 72 are all divisible by? They're all divisible by 4. So I'm going to take out my GCF of 4. Remember, you must always look for a GCF first. Otherwise, the box is not going to work. Okay? If there is a GCF and you don't take it out, your box will not work. Okay? So if I take out the 4, what do I get? Very good. Is there anything in common now with x squared, 7x, and negative 18? Nope. So we're ready to list out our A, B, and C. What's my A? 1. What's my B? 7. And what's my C? Negative 18. So A times C goes on top, which is negative 18. B goes on bottom, which is 7. Has any of us gotten comfortable enough without doing this in the calculator and are able to find the factors without putting it in the calculator? The more you do of these, the better you're going to get at them, okay? But that's why I'm also showing you how to do it on the calculator, because if you need to rely on the calculator, that's okay. So negative 18 divided by x. Go to the table. 1 minus 18 is negative 17. 2 minus 9 is negative 7. 3 minus 6 is negative 3. Skip because it's a decimal. Skip because it's a decimal. 3 minus 6 is 3. Skip. Skip. 9 minus 2 is 7. So my factor pairs are 9 and negative 2. So I'm going to rewrite this as x squared. I'm going to get rid of my plus 7x and write plus 9x minus 2x minus 18. First term, first box. Last term, last box. Middle terms in your diagonal. What are x squared and 9x both divisible by? X. What are x squared and negative 2x both divisible by? X. What are 9 and negative 18 both divisible by? Don't divide them. 9. 9's not divisible by 2. It's not an even number. Okay, if you're telling me 2, you're dividing the two numbers. Don't divide. Tell me a number that they're both divisible by. 9. Do I take out a negative here? No, because the first term's not negative. What's negative 2 and negative 18 both divisible by? Negative 2. And I'm taking out a negative because this time the first term is negative. Check yourself. XX, x squared, x9, 9x. X, negative 2, negative 2x, 9, negative 2, negative 18. Again, are we noticing the pattern of these are always x terms? Sometimes with coefficients, but always x terms. These are always just constants. No variables, okay? So 4x squared plus 28x minus 72 equals, don't forget your GCF we took out at the beginning, and then x plus 9 times x minus 2. Could you check yourself in the calculator? Yes. Yes, sir.
Does it matter like if it's out of the x plus 9, x minus 2, the x minus 2, x plus 9?
The order you write the parentheses does not matter because when you multiply, order doesn't matter. The GCF will always be in front, but if I flip-flopped these, that's perfectly fine. Okay? How many of us would like to find a shortcut to do some of our special cases and don't want to have to do this every time that there's a shortcut? I will tell you, I'm going to show you two different shortcuts. You only can use them whenever they fit the two special cases. Okay, one I think is pretty easy to identify because the name of the special case is literally what you're given. I think the other one we struggle with a little bit more. Okay, So the first one, and I'm actually going to do the second one first, because I think this is the easy one. It's a difference of two squares. Without reading anything, what does difference mean? So it's going to be a subtraction problem. You're going to have two perfect squares. What does it mean to be a perfect square? You take the square root and you get a whole number. So we've been factoring most of these 1, 2, 3 terms. 1, 2, 3 terms. But we did do one that's 1, 2 terms. Okay, so I'm going to show you if it's 2 terms, how we can factor it quickly by identifying that it's a difference of 2 squares. So, first of all, you need to make sure there's only 2 terms. Are there 2 terms? Yes. Is it a difference? Is there a subtraction in the middle? Yes. So it follows both of those requirements. Okay? So I'm going to take the first term. What's the square root of x squared? Just x. Squaring and square rooting undo each other, just like adding and subtracting undo each other, or multiplying and dividing undo each other. Squaring and square rooting undo each other. Okay? Then what's the square root of 49? So are both of these perfect squares? I took the square roots of them and I got whole numbers? Yes. And again, was it a difference? Yes. So that means it's a difference of 2 squares. You're going to do parentheses times parentheses. Leave your parentheses blank, or like leave space, because we're going to obviously write stuff inside of them. Okay? Well, what's the square root of the first term? That goes first. What's the square root of the last term? That goes last. And it's a difference. So what do you think my signs should be? But it's a difference, so the signs need to be different. So one's going to be a plus and one's going to be a minus. If it's a difference of 2 squares, your signs are different. Do we see how they look almost exactly the same, but one's a plus, one's a minus? Yeah. That's all you have to do. Done. If you enjoy using this, please know, can you do every problem like this? No, probably pretty infrequent. But if you're able to identify that you have 2 terms, that you're subtracting, and they're both perfect squares, this will always work. If you don't like this method, can you still do the box by listing out your A, B, and C? Yes, your B is just 0. Okay, because you don't have that middle x term. Good? Okay, next one. Do I have 2 terms? Yes. Is it a subtraction? Yes. Let's see if they're both perfect squares. What's the square root of 9p squared? 3p. What's the square root of 16? So are they both perfect squares? Was it a subtraction? Yes, so this is a difference of 2 squares. Parentheses, parentheses. 3p goes first in both parentheses. 4 goes second in both parentheses. And what's my signs going to be? Opposite signs, plus, minus. Could you put minus, plus? Yeah, same thing. Okay. Is it acceptable for me to put parentheses squared? Why not? Because these are not exactly the same. Yes, we have the same terms, but they're opposite signs. So these are not exactly the same parentheses, so you can't just do parentheses squared. Okay? Again, I think a good handful of us are going to be able to recognize these and factor them this way. Okay? I think the difference of 2 squares is easier because we're so used to factoring 3 terms that it kind of sticks out whenever we only have 2 terms. Okay? Just make sure it has to be a minus sign. If this is a plus sign, does this work? No. Okay? Are we ready to look at the one? The other one is a little bit more involved. Okay? It's called a perfect square trinomial. So again, we're still going to have perfect squares, but this time it's a trinomial. What does tri mean? 3. So it's not going to be 2 terms, it's going to be 3 terms. Probably still my first term needs to be a perfect square. My second term, or sorry, not my second term, my last term needs to be a perfect square. But then how do you get the middle term? Okay? So if your first term and your last term are perfect squares, if the middle term is the square root of the first times the square root of the last, but then doubled, it's a perfect square trinomial. Okay? So let's see how we can identify these. I have 3 terms. Is my first term a perfect square? Is my last term a perfect square? So let's see if this works. Okay, so take your first term. Square root of x squared is x. Square root of your last term. Square root of 36 is 6. So it meets that requirement. Now we need to make sure that the middle term also meets the requirement. Well, what's the middle term? 2 times x times 6. So double what we got when we took the square root of the first term and the square root of the last. So what is 2 times x times 6? 12x. Does that match this middle term? That means this is a perfect square trinomial. Okay? I think these are harder to recognize that it's a perfect square trinomial because sometimes the first term and the last term will be perfect squares, but the middle term does not follow the pattern of 2 times the square root of the first times the square root of the last. But if you're able to recognize it, these are super easy to factor. Parentheses squared. That's the format we follow. What do you think goes first? X. What do you think goes last? 6. Square root of the first goes first, square root of the last goes last. The b term is just going to tell you if the sign is positive or negative. So if it's a plus, this is a plus. Again, guys, I cannot stress enough, if you don't understand this, can you keep factoring using the box like I've taught you the last 3 days? Yes. Some of us are going to be able to recognize these, though, and can do it this way. Are we good with that? Okay, next. Is my first term a perfect square? What's the square root of 9x squared? 3x. What's the square root of 4? So are they both perfect squares? Okay, so what's 3x times 2? 6x, and double it, and we get, so does this follow the pattern? Yep. Okay, because the square root of 9x squared is 3x. The square root of 4 is 2. And then to get the middle term, you do 2 times 3x times 2, and that gives me 12x, which does match my middle term. So that means this is a perfect square trinomial, parentheses squared. What's going to go first? (3x). What's going to go last? 2. And then is it a plus or a minus? Plus. How are we feeling about these? Do anybody really like these? Or do you think you would still just factor using the box? Probably just factor using the box, a lot of us. And again, that's okay, but I do want to show you all this, okay? Next one, what is the square root of 4x squared? 2x. What's the square root of 9? 3. Let's see if my middle term matches that. 2 times 2x times 3. And what do we get? 12x. Don't worry about the sign. Is the term 12x? Yes, so that means it is a perfect square trinomial. Do your parentheses squared. Square root of the first term first. Square root of the last term last. And then your b tells you if it's a plus or a minus. So this time it's a minus. Good? Again, If you don't like any of these 5 types of problems I just showed you, you do not have to use the rules at all. You can factor all 5 of these using the box like we've done. Okay? Are we good? Do you have any questions? No. Okay.